So we've learned about the pressures, the temperatures, and volumes of gases. These three quantities all have different units, which we need to know, we have to have memorized to be able to recognize instantaneously. So let's refresh ourselves on those really quickly. There's two units for pressure, ATM, which is short for atmospheres, and mmHg, which is for millimeters of mercury. For temperature, there's three units, Kelvin, degrees Celsius, and degrees Fahrenheit. And for volume, there's a variety, but the main ones we will use are liters, milliliters, and centimeters cubed, cm cubed. This learning target is all about the relationship between temperature and pressure. If you change the temperature of a gas, how does that change the pressure? If you change the pressure of the gas, how does that change the temperature? Assuming the volume is held constant. So, just to refresh ourselves, the combined gas law, which is on the back of your periodic table, says P1 V1 over T1 equals P2 V2 over T2. This is the equation you need to solve any gas law problems that are not dealing with ideal gases. What we've learned about pressure and temperature is that pressure and temperature are directly related. What does this mean? It means that pressure and temperature change in the same direction. So if you increase temperature, that's going to increase pressure. Or if you decrease temperature, that's going to decrease pressure. They move in the same direction. So if you saw this on a graph, what would this look like? It would look like a line going up. They're both doing the same thing, positive slope. The way to explain this is to think about what is happening to the number of collisions. Always go back to the number of collisions. So if you increase the temperature, the logic that your mind should go through is how is that going to affect the speed of the gas molecules? And then how is the speed going to affect the number of collisions? Because you know that the number of collisions is the same thing as the pressure. If there's more collisions, there's more pressure. So let's apply that knowledge to two problems that all work first for you, then you'll solve two other ones by yourself. Number one reads, a basketball is placed in an oven. What will happen to the pressure of the air inside and why? So we want to know what's happening to the pressure. That's our unknown. Well, let's think about what is happening to the gas in the basketball. Well, if the basketball is placed in the oven, that's going to cause the temperature to go up. If the temperature is going up, that means the gas molecules have more kinetic energy, which means that they are moving faster. If they're moving faster, that means there's going to be more collisions between the gas molecules and the surface of the basketball. If there's more collisions, that means the pressure of the gas is increased. To summarize in a shorter way, if the temperature goes up, the pressure goes up because pressure and temperature are directly related. Number two is a quantitative problem. Number two says the pressure of the air inside the ball was initially 2 atm at a temperature of 300 Kelvin. If the temperature doubled, what is the final pressure? Okay, so let's go ahead and see what we have. Our givens are ATM, which we know is for pressure, and K, which is for temperature. So we're dealing with just pressure and temperature here. So when we use the combined gas law, P1 V1 over T1 equals P2 V2 over T2, we only want pressure and temperature, so we can kind of cross out volume. We don't need to use it. So what this will look like now is P1 divided by T1 equals P2 over T2. So let's plug in our values. Initial pressure, 2 atm. Initial temperature, 300 Kelvin. The temperature doubled, so that means our final temperature, our T2, is going to be 2 times 300. 2 times 300 is 600. And our final pressure, P2, we don't know. So you can solve this in two ways. You could cross-multiply or butterfly it and solve for P2, or you can just recognize if the temperature is multiplying by 2, the pressure has to multiply by 2 because they're directly related. Either way, you get the same final answer that P2 equals 4 atm. So when you're solving these problems, the units for pressure always have to be the same in the initial and the final, and the units for temperature always need to be in Kelvin. Temperature units need to be Kelvin. On the next page, there's going to be 2 problems. I want you to solve those by yourself for practice, and then I'll show you the answers afterwards. So go ahead and solve these 2 problems on your handout. Pause the video right now while you work on them, then you can check your answers afterwards. So the answer for number 2, you bring a balloon to the North Pole. It's very cold. Since temperature is going down, pressure is going down as well. To explain it in more detail, it's because the molecules are moving slower, so there's fewer collisions, which causes the pressure to decrease. In number 2, the setup that you should have had would have been 4 over 260 equals 2 over T2, and then T2 gives you a final answer of 130 Kelvin. If you feel comfortable with this, go ahead and move on to the exit ticket on your iPod or Chromebook and solve those problems there to master this learning target.